presentare.
Thank you for this presentation, dear colleagues. I'm very happy to describe you shortly the new venture for the production of membranes material. Taking into account the increasing demand for desalination membrane materials for different types of water used to produce potable water, as well as the current requirements for industrial water treatment, a new venture was commissioned in the September 2013 near Moscow for the production of flat sheet membrane for reverse osmosis, nanofiltration, ultrafiltration, and the spiral wound elements on their basis. And on this slide, you can see the full-scale plant for the production of this material, divided in a few sectors. You must understand that in Russia, the temperature rise and drop down very dramatically, and we have to keep all time during the year the same temperature, the same humidity. That's why the infrastructure for all these parts of our production site is very complicated. You can see on the left side, the production of ultrafiltration membrane flat sheet. In the center, it's already composite membrane production. And on the right side of this slide, automatic lines for the production of spiral wound elements. And currently, we manufacture all kinds of elements what market need for reverse osmosis, nanofiltration, and ultrafiltration, like I already told. During the past year, we could expand our product range and add it to the standard sizes of brackish water desalination elements under the name K, two different new lines of new elements of series KC and KP, with the minimum salt rejection of 99.4% and elevated flux. And as a result, we are offering now to our customers in this block the maximum wide range, allowing to meet the requirement of each specific water treatment project. But we are not producing only reverse osmosis elements, but also nanofiltration. And during the development of nanofiltration membrane and spiral wound elements on its basis, we initially tried to apply for the production of this membrane common ultrafiltration support on the base of polysulfone. And you can see the structure of this ultrafiltration support on the left side, sponge structure. But what is good for reverse osmosis, not the same for nanofiltration. And finally, we find another polymer, namely polyester sulfone, on the base of which we could get new structure on the right side of this slide with so-called finger structure with the less hydrodynamic resistance to the permeate flow. Is a standard procedure for our production. We control under this parameter, structural parameter, each roll of ultrafiltration substrate what we produce for composite membrane or ultrafiltration membrane. And in this connection, you can see on on next slide, the comparison of the specification of flat sheet nanofiltration and the spiral wound elements on its basis produced using two different ultrafiltration support on the base of polysulfone and polyester sulfone. You see that the both rejection and the flux in the case then we use polyester sulfone much bigger than in case of polysulfone. Of course, the difference in performance is not just based on various structure. It depends also on hydrophilic-hydrophobic balance of the surface of ultrafiltration substrate. And to investigate it, to make some researches, we use special device. You can see its view on the left side, and on the right side, the software interface for measuring contact angle of different ultrafiltration substrate. And what is very interesting, next slide, the data, what you can see here is very, in reality, interesting. Based on the obtained data, we can make the conclusion about the different factors influencing ultrafiltration support contact angle. We use, in reality, different support for the production of different kind of composite membrane. On the last column, you can see the abbreviation in comparison with the analog in Dow classification. And for example, one of the very interesting observation that the polymer concentration, let's compare 0.1 and 0.3, polymer concentration, 17 and 18% already give you the difference in contact angle. What is the most surprising, then you have the same polymer, the same non-woven support for ultrafiltration substrate, the same concentration, but the different producer of the same polymer, I mean polysulfone, namely Solvay and BASF. Let's compare 0.2 and 0.4. You have also different contact angle. And sure, the comparison number 4 and number 5 give you the most dramatic difference in contact angle because this is already the different polymer. And this example clearly demonstrates that the characteristic of composite nanofiltration reverse osmosis membrane in a very, very big part determined by the applied ultrafiltration support. And realizing the fact of the importance of the ultrafiltration support in specification of composite membrane, we pay a lot of attention to its manufacturing without any possible micro defect, and for these purposes we use special device, namely SARTA-Check 3 Plus, to control multi-diffusion test. Unfortunately, the common procedure to test ultrafiltration membrane or substrate, like a flux and rejection towards global albumins, not give you enough of information about the quality of this support. That's why on this slide you can see on the bottom part two different pictures. Left one is a good ultrafiltration substrate. Then the line of the penetration of water or of air through the wetting sample of ultrafiltration substrate in the range from 2 and 5,000 of microbars remain the same. In the case of bad ultrafiltration substrate, its line go up. And we use this procedure to check each single ultrafiltration roll for composite membranes. And also very important, sure, to have the same very careful control of the production of composite membrane, namely the concentration of monomers, and especially the concentration of cross-linking agent. In the case of single cross-linking agent, everything is clear. The band of carbonyl group is a very clear red one on the left side. It's very easy to maintain the concentration controlling the square of this band. But in the case, then we use the mixture of cross-linking agent, and we do it. It's quite difficult to maintain the partition in the mixture, but we were lucky to find the specific for each TMC or IPC cross-linking agent oscillation band of CH links of benzene ring. That's why we can control it very, very carefully. We must understand that despite so tough control of the production of flat sheet membrane, The samples what we use for the test is roughly 10,000 less than the active square in whole spiral wound elements. That's why we decided from the beginning that we will control each single element what we produce and what we send to our customer. And now we have a very sophisticated testing area where everything is automized, and the data what we get on a screen of this department, this is the left side, left and bottom side. The data what we get in the computer, we incorporate in each specification, in the specification of each elements, which give to our customer very big advantage. Because the users, they know that from the place of the elements in the big pressure vessel, depend a lot its life, its, let's say, work during the exploitation. For example, the elements with the bigger flux, you have to place at the end of the pressure vessel, and the elements with the smaller flux, you will load it at the beginning. And in this case, you can keep the hydrodynamic along the pressure vessel more uniform, which give you the possibility to make more longer interval between the CIP procedure and to make the life of these elements longer. Therefore, the described control procedures realized in our plant allow us to guarantee the highest quality and the product's performance stability. That's all what I would like to tell you. Thank you for your attention. In your information, what you have in the bag, there is a small two sheets of information, very brief about our company. Please use it, up to you. If you have the question, we are here with my colleague. He is the chief of our foreign trade affairs. Thank you very much for your attention.